Hey, this is Gwen Logan. It's week 7. I am doing our interactive presentation. It's Monday, September 27th. I'm doing it a little early because I have a busy week this week, but just going to flip this around and show you. So it's week 7. It's called the Ferrofluid presentation. And as you can see, I was able to get some yellow toner from a cartridge that I had. I didn't buy any toner, but I was able to break one open. The next thing I have is some magnets that I found around the house, and we have some olive oil and then a spoon to mix it all up. So before I mix everything up, I do want to go over like what we're going to be doing. And so I'm going to move that over there for now. First thing I want to talk about is what is a ferrofluid. What is a ferrofluid thing? It's a collection of a supraparamagnetic nanoparticles suspended in a liquid. In this situation, the liquid is going to be the olive oil, and the nanoparticles are basically, it's going to be iron oxide that is found inside the toner. So it's going to separate from the gang by using a strong electromagnetic force. And so what a gang is, because I had a little hard time understanding what a gang was, it's a desired material is separated out from the waste material. So the iron, I think, is going to be separated out from the gang, which is, I think, the waste material. But yeah, that was a little confusing what a gang is, but I was able to sort it out. The other thing I'd like to talk about is like what is happening in the ferrofluid solution. So ferrofluid liquid is attracted to the poles of a magnet, and because it is paramagnetic, from our readings this week, we learned that these are attracted to external magnetic fields, and when you compare a paramagnetic to a diamagnetic, basically it has to do with being paired or unpaired. And so a diamagnetic, all the electrons are paired in a diamagnetic, which repels magnetic forces. And this is why the ferrofluid is good, because it's considered a paramagnetism because it has unpaired electrons with a high spin. I drew an example of what that looks like, what an unpaired electron looks like. And you could see, based on the crystal field theory of the splitting, that there's a small change in those difference. And it has a high spin because you see there's 1, 2, 3, 4 unpaired electrons causing that. And that's what makes something paramagnetic. And when you are paramagnetic, the iron and the toner are attracted to the external magnetic fields. I don't know if I explained that well, but we'll go with that. Another thing I kind of looked over was the types of forces that are going on. Like, first of all, the nanoparticles of the iron oxide are suspended in the liquid. Now this liquid, and so they're suspended in the liquid carrier, and then you apply a magnet, then this nanoparticles are either attracted or repelled based on that magnetic field, so you can separate it out. The surfactant, which is actually the olive oil, is very important to this whole thing because it turns out it prevents agglomeration, which is clumping. And so the actual olive oil bonds to the iron nanoparticle and it becomes this ligand. And a ligand is a coordinate, or it's a coordinate bond that is formed with a metal atom. And the metal atom is the iron, and the coordinate bond is the olive oil. And it just makes this nice surfactant for them. There's some van der Waal forces where having molecules within the carrier mixtures are bringing cohesion. So they have that interaction among each other within the fluid, the carrier fluid, as it moves. And there's some Brownian forces that also are providing stability in the carrier mixture, also with cohesion and fluidity. So yeah, I learned that the surfactant is very important in this reaction, and it helps with that. And so I'm going to actually make the product here and see if I can get it to work. So the first thing I have is this yellow toner, and what I'm going to do is very carefully I'm going to have 1 tablespoon of the olive oil, and I'm going to mix it and see if it makes it a nice liquid. I may add a second. This is not 50 mLs. I don't know how much is that, but it's definitely not 50 mLs of toner. So I'm going to go easy and just do 1 tablespoon of the olive oil, mix it up, and see if the magnets will cause some of those peaks and valleys and separation. So I'm going to put this on pause while I make that. Okay, I'm back. I did mix the toner. I don't know, it's not really working. I think maybe the yellow toner doesn't work, I don't know, but I have 3 magnets here and I've tried to get them to work, and I cannot get the separation that we're looking for. I've tried all 3 of them repeatedly, and like this is like a pretty good magnet. So you can see it's a pretty good magnet. It's not really, I don't know if I need to add more liquid, but I keep trying to. Anyway, I'm trying really hard to get this to work, and I don't see any peaks and valleys or anything like that. So I'm gonna try to add a little more oil and see if I thin it out more and see if we get a better result. This is like part 2. I have tried to make it more liquid. I thought maybe that was the problem, but I'm guessing it's the magnets. I'm not getting those nice little spikes that we're supposed to see. We're supposed to see these spikes, and I'm not getting any of that. I keep trying different ways. Maybe I see a little bit of like some bubbles, maybe, but try again. I suspect it's my magnets that aren't strong enough to create a magnetic force to separate them. I'm giving it another shot here. I got 2 magnets here. I'm going to put this here, see if I get anything. Well, I tried. I don't know what went wrong. I'm guessing it's the magnets aren't strong enough to pull out that iron. My gang looks pretty liquidy, so I don't know. Anyway, I tried. I think it's a very interesting experiment. I was looking forward to seeing the spikes and the stuff. So maybe my toner was not appropriate either. I used a yellow toner, so I don't know if that had iron. It should have iron in it still, but those are my thoughts, and that's my presentation on week 7. Thank you.